Hi, this is DrClyde, and we're on step 3 of 6 in optimizing your metabolic exercise. In this step, we're going to look at the big picture on training zones and how they fill the metabolic steps, where if you're missing one, that is your metabolic gap or bottleneck to driving your metabolic rate. Muscle makes up a quarter to half of our metabolic rate, depending on how much muscle we have relative to the rest of our mass and how physically active we are in the past that generates our current fitness, as well as our movement today, regardless of fitness level. The brain is always a fourth, even though it's only 2.5–3% of our total mass. So neurons use about 10 times the number of calories per cell than the average cell making up the rest of your body. The only cells that compete with it are muscle fibers at an all-out sprint or maximally intense voluntary contraction. That's the only other cell type that comes anywhere near close. So first, big picture, what drives our metabolism? Stress management, so stress hormones don't break down our lean tissue. Sleep quality, because deep sleep is where there's an acceleration in gene expression that sets the stage of protein production, the first step for cell vitality and natural healing and growth. And nutrition and our activity levels. In terms of how active we are and the amount of water, protein, slow digesting carbohydrates that we're eating, this is going to determine how much muscle we have. Not necessarily how healthy it is, just how much. Are we doing strengthening? Are we providing water, protein, and a stable blood sugar? That's going to give you your engine size, the amount of muscle. Your fitness comes from nourishing that muscle. Quality foods, which is most important with unsaturated fats and variety of dark colored vegetables. We talked about that in the nutrition mini course. And your cardiovascular fitness level. So the engine size is the demand, the efficiency of that engine is your supply, and moving throughout the day raises your RMR, your resting metabolic rate, by pulling your muscles out of the super relaxed state, which I'll be talking about later. That's my research at UCSF. And you avoid that plummeting resting metabolic rate with the super relaxed state by not cutting calories more than about a quarter of your daily needs. So this gives us a limit for healthy weight loss in terms of how much weight you can lose over time. You can accelerate that with stress management, quality sleep, and movement, but just nutritionally by itself, there are limits. And movement throughout the day keeps your muscles idling even when you're not moving for as long as an hour after a 10-second maximum voluntary contraction. So when you do an activity break for a half a minute, 1 minute, as long as 3 minutes, your muscles can keep idling for a whole hour afterwards. The modern day hunter-gatherers, the Hadza, they have a postural shift every 15 minutes throughout the day, from kneeling, standing, sitting, lying down. So roughly 60 postural shifts a day. And so their muscles keep idling in between those postural shifts. So it's much more important to stand up or sit down or move a little than it is to just stand all the time where your blood is pooling. That's correlated to higher pain levels in the back and the lower limb. So that combination of strengthening and cardiovascular fitness that gives you that supply and demand, and then keeping that engine idling with activity breaks throughout the day, or even just activating your muscles without getting out of a chair. That's the three-pronged approach to metabolic exercise. The model that we're going to use from this class is that every component of fitness matters. Your engine size, efficiency, and the support systems. The size is the force of contractility, your ability to generate power, so that's your strength. Efficiency is your sugar and fat burning capacity, which includes the delivery of those, the health of your lungs, your heart, your circulation, and the support systems, your liver, kidneys, and your immune and endocrine system that's driving the recovery. So the focus is therefore strengthening, cardiovascular exercise, and movement with activity breaks throughout the day. And efficiency targets training zones. You want to sufficiently stretch each specific fitness component, which then generates a DNA gene expression in response to that specific training zone. And by using the largest muscle groups with pushing, pulling, and legs, those are the upper body frontal muscles, the upper body posterior muscles, and then the legs. The legs in the back in particular are the largest muscles in the body. Bicep curls and calf raises aren't going to raise your metabolism very much, even if you're doing 3 hours of those a day. The larger muscle groups are much more efficient. So the compound movements that involve two joints will use the spindly parts, the smaller muscle groups of your body just fine. You can exclude all that from an efficient metabolic exercise program. We're looking mainly for the muscles that cross the joints that are at the periphery of the torso. Those will raise your metabolic rate to the greatest extent. So as you go from movement that you could maintain throughout the day to a higher intensity that you couldn't maintain for much longer than an hour, to even higher where you couldn't maintain it longer than about 10, 12 minutes, to even higher than that where you can't maintain it for more than a few minutes, they have very different effects on the body. They represent different metabolic targets. So now let's break this down in a touch more detail. For strengthening, the highest power output actually isn't the heaviest weight that you can push against or pull. It's the greatest work, which is generally 10, 20% less than that at a high rate of movement. And this is about the rate of movement that we would do a pull-up or a push-up or open or close a heavy door or pick up a heavy box. The rate at which we move things improves the efficiency dramatically, but that represents our highest potential work output, because when you go to the highest resistance that you can push or pull, then the movement slows down and is not necessarily a higher work output. Beneath that highest work output is your maximum force, and that's generally things that you cannot do more than 10 repetitions of pushing or pulling. That approaches your maximum force. Doing a 1 repetition max, of course, a powerlifter and athletes, they do that in competition, but there's a high injury risk for that. So generally, you're going with a half dozen to a dozen repetitions in a set. If you're going more than that, then that starts to shift over to muscular endurance, meaning the muscle's ability to maintain a relatively high power for 24, 36, 48 repetitions or more. The closer you get to hundreds of repetitions, the more it starts to involve your cardiovascular system. So it becomes a resistance and endurance benefit at the same time. So think circuit training, for example. On the endurance side of things, you're using more fats as opposed to sugars that you would be using in the higher intensity exercise. And this is going to increase the rate of oxygen and fat delivery. And when you get to the intensity that you can't maintain for much more than an hour, at that high in intensity, you trigger the fight or flight system, the autonomic nervous system. And this is where we hear these terms anaerobic threshold, ventilatory threshold, and lactate threshold. All of those occur within 5 to 10% of the same intensity of each other. And it is ultimately the autonomic system that drives the majority of those inflection point changes at a 1 hour intensity. So if you're going to go for a walk or a bike ride, and you're not just looking to enjoy yourself, but to significantly improve your fitness level and metabolic rate, then go at a pace that you wouldn't easily be able to maintain longer than about an hour. That is a specific training zone that you can target. So with strengthening, the highest is a relatively high resistance that you can move at a normal cadence with a 1 second cadence. And that is as much dependent on your nervous system as your muscular system. So that is power, maximum rate of doing work. Beneath that intensity is where you're potentially tearing your muscles more because it's a higher resistance, even though you're moving slower. And you're activating satellite cells more as well. And so this is going to increase your engine size. A moderate resistance or moderate intensity, you're shifting not only to getting stronger, but also muscular endurance, where your muscles are able to use fuel more efficiently. And at a lower intensity, you start including cardiovascular. And on the endurance side of things, At the highest intensity, it's mostly sugar use, an all-out sprint that you can maintain for longer than 3 minutes. And if you're at a pace that's you can't maintain for longer than about 10 minutes, this is where you have your maximum oxygen delivery rate. That's called the maximum volumetric flow rate of oxygen, VO2 max. And that is where you have your highest fat burning in terms of calories of fats per minute. At your 1 hour pace, this is your autonomic threshold, as I just discussed. And then if you're going at a lower intensity that you can maintain for longer, significantly longer than an hour, this is where you're getting only benefits to the cardiovascular system. You have minimal amounts of damage to the body that you have to heal from, where you don't have to worry about these arrhythmia risks from doing many hours every day. This is what's correlated to blue zones, where people tend to live the longest. You know, the most supercentenarians per capita, the most people that are 110 years old. Lower intensity movement throughout the day, where the strain and recovery demand on the body is relatively low. So the highest burst output is with endurance type movement as a sprint, and with what we normally refer to as strength training. So strength training, whether it's plyometrics, high or low resistance, and sprints, fall into this category of high rate of fuel use, mainly sugar use. This is something that we do for a few minutes or less. If you're getting stronger from an activity, you're probably not going 10 minutes straight with that with repetitions that last that long. That is more of a cardiovascular exercise at your VO2 max, your maximum volumetric flow rate of oxygen delivery and use, and therefore your maximum fat burning rate. And your hour pace is, which doesn't mean you have to do these things for 10 minutes or an hour, but rather it's the pace that you could potentially achieve that duration. I mean, you could do your hour race pace for only 30 minutes. That is your threshold pace where you're significantly increasing your fitness from the effort. And the lower intensity, which is more properly the cardiovascular pace, that minimizes the damage on the body. And the activity breaks throughout the day, at least every hour, is our non-exercise activity thermogenesis, NEAT, N-E-A-T, that keeps our muscles idling throughout the day and can burn as much as 500 calories throughout the day from just 100 calories worth of movement because of the idling effect. So we can gauge how close we are to sugar burning anaerobic as opposed to almost entirely fat burning at the very low intensities, and in the spectrum in between, as you're gear shifting between those two, based on how easily you can talk. At the highest intensity, you can't talk. And at the VO2 max pace, your 10-minute race pace, you're going to have strained speech, but you can talk, at least in the first half of it. If you're doing something at a 1 hour pace, it becomes harder towards the end, but in the first half, speech is relatively easy. And for a lower intensity pace, speech is fine. So you can use your ability to talk as a relative gauge for your intensity. You don't have to go to a lab and get any fancy testing done. And if you're tired at an hour, you know that is that relative pace. If you're tired at 10 minutes, then you know it's at that pace. If you're tired within 3 minutes or less, then you know that it's in that pace for that training zone.